Hi friends, you must have heard of causal masks. Essentially, causal masks is a matrix where the lower triangular positions are all 1, so that it prevents one position's token ID from interacting with the future position token ID. This is to avoid the informational leak. This sounds simple. However, today we're going to dive deep into what's actually used in production system, in training large language models, and in training recommendation systems. So let's get started. So let's first talk about the vanilla causal masks. So the reason why we have causal mask, as we just talked about, is that in attention we have Q key V is Q multiply K divided by D and then soft max and then multiply V. So what we're concentrating and where the mask is applied is after this K and Q. So this is where causal mask is applied. So the reason why is that this one generates an n by n matrix, and this n by n matrix is basically counting the interactions of n by n items. So every item in the sequence interact with all other items. And causal mask is usually applied as a decoder architecture. Essentially, what we don't want is that the current item has information about future IDs. So that's why if you look at the query here, so this is a query position and this is the key position. So let's say each position is ij. What we're saying is that if you're a query token, you only have information to you yourself and all the previous tokens. So this can be expressed as if I is greater than j, then you preserve the attention. Otherwise, this query token should have no information with the future token. So with that, this is a vanilla causal mask. We also have sliding window causal masks. So previously we said if I is greater than j, then preserve. If I is less than j, then just forget about it. You shouldn't have information about future token. So with sliding mask, what we're talking about is that, so for this query, for this token here, you also shouldn't have information about tokens too far away from you. So this is especially common when you have a very long sequence, see like thousands of tokens. You only want your current token to be relevant to the tokens within the sliding window. What essentially means is that you want I to only care about tokens that not too far away and within the sliding window sequence. So essentially want I minus j is less than w, your window size. So several examples you can see here. This is a query position, this is a key position. What the window size is w is equal to 3. You want, say this is I is 2, this is 2 0, this is 3 1. They all satisfy these 3 criteria. Okay, this should be 1. This is sliding window causal masks. It's irrelevant when you are processing long sequence. And next, we talk about document mask. So document mask is especially common in the large language model training when you have documents from multiple sources. So for example, I have document A is about fashion article, and document B is about world finance, and document C is about celebrities. So each document is independent. You don't want to say when you are querying tokens in document B, you don't want this token to have interactions with document A. In that way, you would dilute the result. So this is also a causal mask, but the causal mask applied at document level. So the queries in document A only have access to previous tokens within document A. Similarly for document B and C. So this is very common for the pre-training in large language models. And lastly, we'll talk about the target-aware attention mask. So it is sort of similar to the document attention mask, in that for document, you have document A, B, and C. And for target-aware attention mask, you have your history, and you also have your targets. Essentially, each target are the prediction candidates. Target-aware attention is saying These three targets, 1, 2, 3, they are able to see the user history, but they are by themselves. They shouldn't be able to see each other because they are all prediction candidates. Think about this as a shopping scenario. The history is user's previous shopping history, and the targets are what the user bought in this one shopping session. So all the items in these shopping sessions are targets, and they all have visibility to the user's shopping history, but each of them should not interact with each other. Target-aware attention mask is very commonly used in shopping recommendation, social media recommendation. Talk about 4 types of causal masks, starting from the most basic vanilla causal masks to sliding window causal masks, and then to the document mask, which is commonly seen in LLM training, and lastly to the target-aware mask, which is commonly used in recommendation tasks. So that's it. Thank you for watching. We'll see you next time.